Year 10 Computer Science introduces fundamental programming and computational thinking concepts that form the foundation of all computer science learning. Programming fundamentals include five core areas. Variables act as data storage containers, holding information your program needs. Data types define what kind of information you can store, such as integers for numbers, strings for text, and booleans for true or false values. Operators allow you to manipulate data through arithmetic calculations, comparisons between values, and logical operations. Control flow structures like if-else statements and loops give your programs decision-making abilities and repetition capabilities. Functions are reusable blocks of code that perform specific tasks, making your programs more organized and efficient. Most students learn these concepts using Python or Java programming languages. Algorithms are step-by-step instructions designed to solve specific problems efficiently. You will learn to design, analyze, and implement various types of algorithms. Searching algorithms help you find specific data within collections. Linear search checks each item sequentially, while binary search uses a divide-and-conquer approach for sorted data, making it much faster. Sorting algorithms arrange data in a specific order. Bubble sort compares adjacent elements and swaps them if needed, while selection sort finds the smallest element and places it in the correct position. Understanding how computers store and represent data is crucial for computer science. All information in computers is ultimately stored as binary numbers using only zeros and ones. Text is represented using encoding systems like ASCII and Unicode, where each character is assigned a specific number. For example, the letter A is represented by the number 65 in ASCII. Images and sound are also converted to digital formats. Images use pixels with RGB color values, while sound is sampled at regular intervals to create digital audio files. Computational thinking involves four key problem-solving strategies that help you approach complex challenges systematically. Decomposition means breaking down complex problems into smaller, more manageable parts that are easier to understand and solve individually. Pattern recognition involves identifying similarities and recurring themes in problems, which helps you apply known solutions to new situations. Abstraction means focusing on the essential details while ignoring unnecessary complexity, helping you create simplified models of real-world problems. Algorithm design brings everything together by creating clear, step-by-step instructions that solve the problem efficiently and can be implemented in code. These four core concepts form the foundation for all advanced computer science topics you will encounter in your studies and future programming projects. Programming projects form the heart of practical Year 10 computer science learning. These hands-on experiences transform theoretical knowledge into real-world skills. Students create simple games that teach fundamental programming concepts like loops, conditionals, and user input handling. These projects make learning engaging and interactive. Calculator projects teach students about mathematical operations, user interfaces, and error handling. These practical tools demonstrate how programming solves everyday problems. Advanced students work on simulations and data analysis tools, learning to model real-world scenarios and extract insights from information. Computer science education must address the ethical and social implications of technology. Students learn to think critically about the impact of their future work on society. Data privacy is a critical concern in our digital age. Students explore how personal information is collected, stored, and used, learning to protect both their own and others' privacy. Cybersecurity education teaches students about digital threats and protection strategies. Understanding these concepts is essential for responsible technology use. Data structures are fundamental ways to organize and store information efficiently. Year 10 students get their first introduction to these essential programming concepts. Arrays are ordered collections of elements, like a row of boxes where each box holds one piece of data. Students learn to access and modify array elements using index numbers. Lists are more flexible data structures that can grow and shrink during program execution. Unlike arrays, lists can easily add or remove elements as needed. Web development introduces students to creating interactive websites using the fundamental technologies of the modern web. HTML provides the structure and content of web pages. Students learn to create headings, paragraphs, links, and other essential web page elements. CSS controls the visual appearance of websites, including colors, fonts, layouts, and animations. Students learn to make their websites visually appealing and user-friendly. JavaScript adds interactivity and dynamic behavior to websites. Students create buttons that respond to clicks, forms that validate input, and other interactive features. Year 10 Computer Science opens doors to exciting future opportunities in education and careers. The skills developed form a strong foundation for continued learning and professional success. Students can continue their computer science journey through A-levels, university degrees, and specialized courses. Each level builds upon the foundations established in Year 10. The problem-solving, critical thinking, and creativity skills developed in computer science are valuable across many career fields, from technology to business to creative industries. Year 10 Computer Science provides a comprehensive introduction to the field, combining theoretical understanding with practical application. Students emerge with both technical skills and the confidence to tackle complex challenges in our increasingly digital world.